So where does that lead us or leave us? That leaves us with, what do we do next? How do we use this? Great, we know what scale factor is, but what do you do with it? You've got to do something with it. So let's put it to use. How many times bigger does the big triangle look than the small one? 2, 2.5, maybe 3 times. Okay, well, we've attached some value to it. The 2 is in the 6's. These are the corresponding sides. So now we can find the scale factor. So 2 times something gives me 6. Well, I recognize right away that that's 3. So 2 times 3 gives me 6. So if this side here is 3 times bigger, then this side also has to be 3 times bigger. So 5 times 3, x must be, 5 times 3, x must be 15. Okay, easy enough. Now there's this other cool thing called ratio. And ratio is the sides together. So not scale factor, but ratio. So let's start over here. So instead of going from triangle corresponding side to other corresponding side, we're going to stay within the sides of the same triangle. So the 2 to the 5. So I'm just going to set it up like this, just like division, like 2 divided by 5. I could do it as 5 divided by 2. I just chose to do 2 divided by 5. And that has to equal, because we're saying it's corresponding, that has to equal 6 over x. Okay, so short side on top, big side on bottom. Short side on top, big side on bottom. Okay, so you could do scale factor here, 2 to the 6. But I don't want to do scale factor. I want to try ratio out. Let's see if we get the same answer. So what is 2 divided by 5? Punch in the calculators, that equals 0.4. So this side also must equal 0.4. So 6 divided by something gives me 0.4. Well, it's got to be a bigger number down there. And you could play around. Eventually, you would do 6 divided by 0.4. Replace the x, and that's going to equal 15. So no matter how you do it, 6 and 15, 2 and 5, whether you use scale factor or ratio, you get there. And what I encourage you is, if you really understand ratio, then solve it with ratio. If you really understand the scale factor way, then do scale factor. If you don't get both of them, that's okay, as long as you get one really well. All right, that leaves us up to a shadow problem. Shadow problems and mirror problems are very similar. Okay, so we got this dude down here, and he's flying his kite. He's 5 feet tall, and he recognizes that his shadow is 4 feet tall. He's flying his kite, and the kite's shadow is 15 feet long. He measured it out. How high is the kite? Okay, so in this situation, we basically have 2 different triangles. We've got the 5 by 4, 5 foot by 4 foot, and we've got the bigger dude, 15. Oh, I'm sorry, 15 is on the wrong side there. 15 is on the base here. 15 feet by, we don't know. That's what we're trying to find out. So 5 feet by 4 feet, x by 15 feet. Same situation as what we just did. We could do ratio, we could do scale factor. Okay. Right away, I don't necessarily recognize a scale factor from 4 to 15, but I can find it. I can find it really quick. So how do I get from 4 to 15? Well, I could divide backwards. 15 divided by 4. And that equals, punch it in the calculator here, 3.75. So my scale factor is 3.75. That was the division, 3.75. So that means that this guy is 3.75 times bigger. Okay. So 5 times 3.75. His kite is 18.75 feet high in the air. So my scale factor from 4 to 15 was 3 3/4. So that must mean my scale factor from 5 to x was also 3 3/4. Okay, now let's try this ratio way. I'm going to do ratio way in red. Okay, so 5 over 4, 5 feet over 4 feet has to be the same thing as x over 15 feet. So x amount of feet over 15 feet. So height to shadow, height to shadow, height to shadow. Okay, so what is 5 divided by 4? 5 divided by 4 equals 1.25. Therefore, this side must equal 1.25. So what we're saying basically is that he is 1 1/4 times bigger than his shadow. Therefore, the kite, because the sun casts the same angle, the kite has to be 1 1/4 times bigger than its shadow. So we'll just figure that out. What is 15 times 1.25? It's also 18.75 feet. So same situation. Please do not get freaked out by the fact that we've got this weird drawing of a kid and the kite, and we've got to find out how tall the kite is. It's the same thing as if we just put it up as 2 triangles and find the missing side. Same with a mirror problem. A mirror problem would be this. We've got 2 triangles that face each other, and they're similar. They share the same angles here and here. Okay? They share the same angles, and then you would find the missing side here, and this would be 2, and this could be 5, and this could be 7. You know, whatever. You could find x. Doesn't matter. Okay? And then the inside the triangle thing, I want to talk about that. All right? Let's draw this situation real quick. This will be the last thing we do. This is a great test question for the OAAs. Okay? So we've got this triangle here. And then there's another triangle with inside it. Okay? And we know that this part right here is 10 feet. This part, the remainder of that side, we don't know. Okay? Now we know that this bottom leg here, and on the one on the inside of the triangle, this is 15 feet. And then down at the bottom is 20 feet. Okay? And we got to find this small section right here in red. How do we do that? Okay, well, we basically have 2 triangles here. Okay? We have this triangle here. If we just pull it out, we can move this thing with it. Okay, that's 10 feet. We know that this is 15 feet. And we know that this little x portion, we don't know what it is, but we can find it because we can just subtract it from this, which we know is 10 feet. Okay? So we have the 10 to 15 and the 10 plus x to 20. I'm going to do ratio. So what is 10 divided by 15? 10 divided by 15 equals 0.3 repeated. Okay, so we're saying that, I'm sorry, 0.6 repeated. What am I doing? The upright leg is 2/3 the size of the base. Okay, so now we know that. Can we find what this total leg here is? Yeah, we can. Okay, so what is 2/3 of 20? Well, let's punch that in our handy-dandy calculator. And it's 13.3 repeated. Okay, so this whole side is 13.3 repeated. But I don't want to know the whole side. I only want to know this much right here, the x. So what would you do? Yeah, we know that this is 10. I don't want the 10. I just want that little leftover spot. So I know that x equals 3.3 repeated. 13.3 repeated minus 10 equals 3.3 repeated. Feet. Don't forget the feet. Won't get full credit. Okay, so this is a nested triangle type problem. I know this video was a little long. There was a lot of stuff jam-packed into it. Break it down, and then once you go through and find your scale factor, you can find how much bigger is it, okay? How much area difference do I have? If you wanted to do scale factor in this problem here, you could go from 15 to 20. How do you get from 15 to 20? Well, divide 20 by 15 and find your scale factor, and you can now find the other side because you have your scale factor. All right? So, again, good luck to you as you explore and learn new math.